Hi, I'm Rafi Arel. I'm the CEO of Opsys Tech. Today, I would like to talk with you about our exciting technology for a true solid-state scanning LiDAR solution. In this session, I would like to talk with you about the market, the technology, our company, and even a little bit about our potential customers and partners. Let's talk about the market first. The LiDAR market is huge. People talking about $20 billion annual revenue by 2030. It's reflecting a CAGR of 80%, which is significant. Our technology enables the industry to get the full range of applications. In fact, with the same technology, we are able to address from the ADAS up to the high level of autonomous driving L5. It's true that the LiDAR market is saturated. There are many LiDAR companies around. However, wherever we reach with our technology and solution, we hear that tier ones and OEMs are still looking for the right solution. All the doors are opened. Our technology is being tested now by global leaders in this market. Specifically, we are in advanced stages of testing with major European, Asian, and also North American automotive OEMs for both ADAS and L3 projects. Some of those projects could start as early as beginning of calendar year 2023, their production phase. In addition, Opsys has already signed few agreements both with Korean Tier 1 and major Chinese Tier 1 for deploying our technology in these locations, the OEMs in these locations. In fact, we are also in a very advanced stage of discussions with major European Tier 1 and a major Korean Tier 1 for projects that will commence in the next few years. Talk a little about technology. Our system is a scanning LiDAR, but it has no moving parts, absolutely zero moving parts. We are using two main components. For the transmitter side, the illuminator, we are using a fully addressable VCSEL array, which is the first in the market. And on the detector side, we are using a very high density SPAD array, which is actually an integrated chip with signal processing. These two components together enable us to get to a top performance LiDAR solution, meaning very high detection range, more than 200 meters at 10% reflectivity, very high resolution, and very fast system. All this obviously an eye-safe solution, and it is in the range of the 900 nanometer, which is the near infrared range. That's key for cost. Our technology enables to get the top point cloud density in the market, which is key aspect, key metric for perception, and that's the actual use of the LiDAR at the end of the day. Also, these wafer scale components enable us to get to the right cost, but because they are very reliable technologies, they allow us to get to the full system reliability required for automotive industry. Specifically, very wide range, temperature range between -40 to 85 C, and also all the vibration and the tough automotive requirements which are must for this type of products. Our technology enables us to get to the right cost, and this is because these are all wafer scale processes. They actually makes this product a semiconductor device. So components are cheap, low cost at high volumes, very simple assembly, and this can drive the total cost of the system to the level required by automotive industry customers. Obviously, all this wrapped with a very wide and significant IP we filed during the years in order to protect our technology and solution. A few words about our management team. Our team is built from veterans from the telecom industry. All the team was involved with very high volume products delivered to the telecom and datacom market. Specifically, we are very experienced with the VCSEL arrays technology, which is used in high volumes in smartphones for time-of-flight camera and facial recognition. And also, we had a vast experience delivering very complicated optical-based products, such as reconfigurable ODMs to the telecom customers for very critical optical networks. Our team is backed up by significant investors. We have investors from the US, Translink Capitals, and Osage Partners, and we have a major investor from Israel, 83 North. And in addition, we have a very strategic partner, strategic investor, which is HKMC, Hyundai Kia Motors Company from Korea. So let's see how this system works. We mentioned before the VCSEL arrays and the detector. So this is what you see here in this movie. I'll run it shortly. Just before that, few words. This is representative generic block for our system. We call it TRX, and it has the VCSEL arrays, the addressable arrays, and the detector. Let me run the movie and quickly brief the system operation. So what you see here is actually a scanning. Each VCSEL will fire a laser pulse towards the scene. The detected signal of the return pulse from a specific spot in the scene will be detected by few pixels at the detector side, and we will select one of those through some signal processing algorithms and decide which one is the best to represent that point. And that will drive us the X, Y, and the time of flight will give us the Z, the range. What you see here, this is all electrical switching. So basically no moving parts, however, going through a specific field of view by just switching on and off lasers. The system is very fast, and in fact, every point, every measured point is represented by multiple measurements, and the results at the point cloud is that the probability of detection or the range is significantly improved to these multiple measurements. Another major differentiator of our technology is its modularity. It's actually the architecture. So what you see here is a vehicle where it needs to cover few applications: long-range LiDAR, mid-range on the sides, which is lower resolution, and even short-range LiDAR with even lower resolution. In this example, it's 0.4 by 0.4. Our system is able to address all these with the same technology and just replacing the lenses. Actually, it allows much better cost-effective solution. We are able to cut the cost of the hardware in order to optimize these areas which are not necessarily the top performance. And in our case, because we have a very unique IP, which using multiple wavelengths between sensors, we are actually able to work all in parallel, full parallel processing of all this solution while scanning each individual area in parallel to the others, as opposed to other companies that may, or other technologies that they may need to synchronize between these and reduce the scanning time or reduce the field of view or the resolution in order to address all this coverage. This is an example to show when I was talking about building blocks, these TRX that we have seen before in one of the previous slides. You can see an example of how this could be integrated into a system, into a car. And we could use different building blocks, you see TRXs, in a specific structure with specific wavelength and even lenses to get the coverage of specific application in the most cost-effective way. These are examples of point clouds, a pure raw data of our system. No image processing, no perception processing here. It's a pure measurements, time of flight measurements of our system. And you could see the richness of the point cloud density. I'll run this movie so you can see a drive test we've made in one of our test drives. What you see here is actually a mix of long-range LiDAR sensor in the middle, and on the sides it's a 0.2 by 0.2 resolution. And you can see how this actually covers very well the scene with no need to compromise and in a much better cost-effective way. As previously mentioned, we are now in few demonstrations, POCs worldwide. Both Tier 1s and OEMs are testing our systems, and I try to share with you some of the feedbacks we get. Definitely, it's very noticeable. People are talking about the high performance, the resolution, the point density, the long range with a very high probability of detection. Some people talk about the reliability. Obviously, for trucks, reliability is a key for heavy trucks. Vibration, solid state is the right solution in the long term. These are all sharing our view that we're bringing the best solution to the market. Before we finish, I would like to share with you our roadmap and actually also some of our history. So far we have introduced to the market 2 prototypes. The recent one, we call it SP2.5, is the one that is demonstrated and tested by various Tier 1s and OEMs. Both were showed at CS shows in Vegas in previous years. We are heading up with the next version, which is actually, we call it a compound version. This is a single box that will incorporate few of our modules, generic modules, TRX, with various resolutions in order to address in the best cost-effective way a specific field of view with specific application. Thank you very much for your time today. I appreciate your time for listening to my speech. If you have any question or you need any information, please feel free to send me an email. Thank you very much and enjoy your rest of the day.